In section 2.3, number 1, we learn how to graph quadratic functions. As is explained in the notes, the graph of every quadratic function is a parabola, which is sort of a U or bowl-shaped graph. So to graph a parabola, there are a few special points that we need to be able to identify, particularly the vertex, the y-intercept, and any x-intercepts. For the x-intercepts, there could be 1, 2, or for that matter 0. There could be no x-intercepts. And we'll see some examples of that. But first off, looking at example A, part A, we have the quadratic function f of x equals x squared minus 2x minus 8. Now to begin with, it's a good idea to identify and actually write out what a, b, and c are. So a for this quadratic function is 1, because I basically have 1x squared. B is minus 2, and c is minus 8. Okay, so if you've read through the notes, you've seen, in part 1, we're asked to find the vertex, which if you've read through the notes, you saw that the vertex, the x-coordinate of the vertex is found by using the formula minus b over 2a. So that would be minus a negative 2 over 2, or a positive 1. And the y-coordinate we obtain just by plugging the x-coordinate back into the function. So let me clean that up a little bit. So I calculate f of 1, which gives me 1 minus 2 minus 8, which would be 1 minus 10, or negative 9. So that's the y-coordinate of the vertex. Okay, so the vertex is the point 1 minus 9. So we need to sketch that out on the graph. For part 4 here, we're going to sketch the graph of the function. So we're going to do that in steps as we go along. So the vertex is at 1 minus 9. So let's use the scale. Each square here represents 2 units. So this would be x equals 1, and minus 9 would be down here. So the vertex is this point right there. Okay. So in part 2, they ask us to find the x-intercept. The y-intercept. That's simple for a quadratic function. To find the y-intercept, you just plug 0 into the function, x equals 0, and that gives us minus 8. So y equals minus 8 is the y-intercept. Okay, so plotting that, we already have it drawn here, where I have minus 8 marked off. So if I just kind of shade that in a little bit, this gives me my y-intercept. Now, the final thing I need to do to get a decent sketch of the graph of this function is to find the x-intercepts. So the x-intercepts usually are found either by factoring the equation, factoring the function, or using the quadratic formula. Now, generally speaking, 9 times out of 10 in this class, we're going to use the quadratic formula because the functions we're going to be working with just don't factor in a nice way. But this first example is one that does factor. So if I take f of x, first off, to find the x-intercepts, what I need to do is I need to set the function equal to 0. So I take x squared minus 2x minus 8 and set that equal to 0. So like I said, this particular example factors into x minus 4, x plus 2. If you don't really remember how to do this factoring, don't worry about it too much because not every problem does factor, but on every problem you can use the quadratic formula, and we'll discuss the quadratic formula in more depth as we go on. But you can always use the quadratic formula. But anyway, once we've factored this, we see that this equation has solutions when x is equal to 4 or x is equal to minus 2. Those are the values that make that previous equation equal to 0, and hence these are our x-intercepts. So sketching those in, x equals minus 2 would be right here, and then x equals 4 would be over here. So this gives us 3 points on our graph, and I can get just a really rough sketch here of what the graph would look like, the graph of this parabola. And sketching this out, it's kind of hard to sketch this on this tablet, but I get a picture that looks a little like that. That would be our parabola for this function x squared minus 2x minus 8. Okay, and in fact, just to make it a little clearer, let me label the vertex. The vertex here is 1, minus 9. Okay, continuing on. In part B, it's the same idea, except the function we're working with now is f of x equals minus 4x squared minus 8x plus 5. So just like before, I'm going to start by identifying what A, B, and C are. So A in this case is minus 4, B is minus 8, and C is 5. Okay, so to find the vertex, we use the formula x equals minus b over 2a, which gives me minus negative 8 over negative 8, so that gives me negative 1. And then the y-coordinate is found by plugging minus 1 into that function. F of minus 1 equals, so let's see what we'd get here. Negative 4 times positive 1 minus 8 times negative 1, so that's plus 8 plus 5. I got a positive 9. Okay, so the vertex here is going to be at the point minus 1, 9. And so let's see, minus 1, and let's see, 9 would be right up here. So we'll label the vertex here, minus 1, 9. It's also worth noticing that if we look at A, we see that A is negative. So we can glean some information out of that. The fact that A is negative means that our parabola is going to be opening downward. So that's important to remember. That's going to save you a little bit of time on certain problems. But continuing on with this problem, in part 2, once again, we find the y-intercept. So to find the y-intercept, we just plug 0 into the function. Plugging 0 into the function here, we get 5. So 5 is the y-intercept. And shading that in, 5 would be right here. Okay, so we can get a little bit more of an idea of what our graph looks like now. It's going to look something like that. And the next thing, I just need to figure out where my x-intercepts are going to be, where this parabola actually hits the x-axis. Okay, so to do that, just like before, I set my function equal to 0. So setting it equal to 0, I have minus 4x squared minus 8x plus 5 equal to 0. Now we can try, but this equation is not going to factor very nicely. So when our functions don't factor, when we have a quadratic function that won't factor, we need to use the quadratic formula to solve it. So you can refer to the notes to get a review of the quadratic formula, but basically the way it's going to work is this. The solutions to this equation, minus 4x squared minus 8x plus 5, are going to be given by the following formula. X equals minus b, so minus negative 8, that's positive 8, plus or minus the square root of 64 minus 4 times A times C. Okay? And so divided by 2A, so divided by minus 8. So because of this plus minus in the formula, I'm actually going to get, well, most likely I'm going to get two solutions. One where I use the plus and one where I use the minus. So continuing on a little bit. So I'm going to simplify everything under the square root. And if you go through and calculate that, 64 minus 4 times negative 4 times 5, that turns out to be 64 plus 80, or 144. And in fact, that is going to simplify to 8 plus or minus 12 over minus 8. So that's going to give me two solutions. One where I use the plus and one where I use the minus. So writing those over here, I have x equals 8 plus 12 divided by minus 8. And then if I calculate that, 8 plus 12 over minus 8, that's going to be 20 over negative 8. And that turns out to be minus 2.5. For the other solution, I have 8 minus 12 over minus 8. That's negative 4 over negative 8, or positive 0.5. Okay, so these are my x-intercepts. And so plotting those, x equals 0.5 is going to be right here. Because remember, this is 2, so it's going to be kind of a quarter of the way through that block. And minus 2.5, this is minus 2, so minus 2.5 will be right around here. Okay, so connecting up the dots, I get something like that. So, and it's a good idea, especially if I'm kind of using this funny scale here, it's a good idea to label my x-intercepts. Okay. So it's a really sketchy, sketch of the graph, but hopefully you can kind of get the idea of what it looks like here. Okay, so moving on. We'll start to move through the remaining examples a bit quicker. You can always refer back if you forget how to do something. So in part C, we have the function f of x equals minus 2x squared plus 7x minus 3. So we start by finding the vertex. So the vertex, I use minus b over 2a. Oh, in fact, let me go ahead and denote. A here is minus 2, b is 7, and c is minus 3. So minus b over 2a, that's going to give me negative 7 over minus 4, or 7 divided by 4, 1.75. Okay? So the y-coordinate is f of that, so I just plug 1.75 into this function. And so if I go up and calculate this, I'm going to have, let's see, negative 2 times 1.75 squared plus 7 times 1.75 minus 3. This gives me 3.125. So I get this somewhat ugly decimal, this point with these decimal coordinates. Okay. So let's see, if I sketch this point out, 1.75 will be right around here somewhere, just short of 2. And 3.125, well, let's see, this is 3, so just above that is going to be 3.125. So this is my point, this is my vertex, 1.75, and then 3 and 1/8, 3.125. Okay, again, looking at the coefficient on x squared, or in other words, looking at a, I see that a is negative. The fact that a is negative tells me that this parabola is going to be opening downward. Okay, so next, let's find our y-intercept. Let's see. So the y-intercept, to find the y-intercept, I plug in 0, f of 0, that gives me minus 3. Okay, so that's right down here, minus 3, that's our y-intercept. Now for the x-intercepts, we are once again going to have to use the quadratic formula. And so this is going to give x equals minus b, so it's negative 7, plus or minus the square root of 49 minus 4 times a times c. Well, okay, so let me just write this out. 4 times a times c over a squared, so over minus 4. So I get, simplifying this stuff under the square root, I get minus 7 plus or minus, let's see, 49, I believe that's going to be 49 minus 24, so that's a square root of 25, divided by 4, or negative 7 plus or minus 5 over 4. And then I'll let you go through and calculate those, one for the one solution using plus and one solution using minus. But that's going to give you 0.5 and 3. So just double check that and make sure that you get the same answer. And if I plot those, 0.5 is going to be right here, and 3 is going to be right there. So that's going to give me the following sketch for the graph of this function. Again, I apologize, this sketch is not terrific. It's a little hard to draw on this thing. And I'm going to label those points, those x-intercepts. That's 0.5, and this is 3 which is 3. Okay. Well, 3 more examples to go. These next couple are going to go a little bit quicker, though, I promise. Okay, part D. We have the function f of x equals 2x squared plus 4x plus 5. So our a, b, and c are 2, 4, and 5. So let's see. The vertex is going to be x equals minus b over 2a. So that's just minus 1. If I've done that right, let me just double check that. B over 2a. That looks right. So y is going to be f of minus 1, which is going to be 2 minus 4. Which is negative 2 plus 5, which is 3. Okay, so the vertex here is at minus 1, 3. And plotting that, minus 1. Hey, let me actually use a slightly different scale here. I think this will fit on if I just use one block per number, or one block per unit. So this will be minus 1 up here, and then 3 will be there. So this is the vertex minus 1, 3. In fact, let me label that down here. Minus 1, 3. Okay. So now let's find the y-intercept. I set x equal to 0. So y equals f of 0, which gives me 5. So my y-intercept is at 5. Okay, so now here's where we have a slight shortcut on this problem. Notice if I look at A is positive, so that means the parabola is opening upward. In fact, we can actually see that from the fact that the x-intercept is higher than the vertex. So if you can tell that a sketch of this parabola is going to look a little bit like this. Since it opens upward, and the vertex is higher than the x-axis, that means this parabola is never going to hit the x-axis. And these arms of the parabola just continue to go up and up. So as an upshot of that, I can tell automatically that there are no x-intercepts. So I can tell that just by looking at the picture and kind of by using sort of geometric reasoning. If you wanted to use the quadratic formula, you could. When you set it up, you would get something like x equals minus b plus or minus the square root of b squared minus 4 times a times c. I encourage you to go through and calculate this, but what you're going to see is that the stuff under the square root turns out to be negative. And since we can't take the square root of a negative number, that means we won't have any solutions in this case. Okay, but it's much easier just to kind of think through the problem based on where the vertex is and the fact that the parabola opens up. If this parabola had opened downward, then we would get x-intercepts. Okay, just 2 more quick examples. There's a similar shortcut that we're going to be able to use on E, but it's not exactly the same. So our function is 3x squared minus 12x plus 12. So part I is to find the vertex. So as before, let's write down A is equal to 3, B is minus 12, and C is positive 12. So our vertex is going to be x equals minus b over 2a. So, whoops, that's minus negative 12 over 6. So what's that going to be? It's going to be a positive 2. And y is f of 2. So if I calculate that, let me just take a quick look here. I think that gives me 0. It's 3 times 4, which is 12, minus 24, which is negative 12, then plus 12 takes me back up to 0. So 2, 0 is the vertex. And that means my vertex is right. Let's say this is 2. Okay. Now again, this parabola opens up. So I can tell that the picture is going to look a little like that. But the fact that the vertex is actually already sitting on the x-axis means that there is no other point where the vertex, or where the parabola hits the x-axis. This vertex is going to be our one and only x-intercept, which is nice because that's going to save us from having to use the quadratic formula in step 3. Okay, but we still need to find the the y-intercept. To find the y-intercept, we just plug 0 into the function, f of 0, and that gives us 12. So y equals 12 is the y-intercept. Okay, so I obviously used kind of a poor scale here. So this is let me use a slightly different scale on the x-axis and the y-axis, just for the sake of getting this picture. Let's say this is 12. Okay, in that case, my parabola looks something like this. Okay, and so as I mentioned before, I can tell from the graph already that there's only one x-intercept. That's at x equals 2. If I did not notice that from looking at the graph, I could obviously still use the quadratic formula. Doing so, if I set it up, I would get x equals 12 plus or minus the square root of b squared, which is 144, minus 4 times a times c, divided by 2a. Now what happens here, and again I encourage you to kind of work through this, but what happens here is if I calculate the stuff under the square root, that all turns out to be 0. So the square root of 0 is 0. So the plus and minus here doesn't really matter, because whether I'm adding 0 or subtracting 0, I'm going to get the same thing. Regardless, it's going to be 12 over 6, which is 2. So you can see how you would only get one solution for the x-intercept in this case. That's just x equals 2. Okay, So one last example. Part F, we have the function f of x equals minus 4x squared plus 16x minus 7. I'll tell you what, for the most part, I'm going to leave, I'm just going to kind of choke through the work here, and then I'm going to leave it to you to actually, you can work through it as well, and then you can compare with my answers to check what you found. But this is what I got for A, B, and C. Minus 4, 16, and 7, negative 7. So the vertex is going to be at minus b over 2a. So I believe that's going to be 2. Let me just double check that real quick. Yeah, that looks like 2. So the y-coordinate for the vertex is going to be, let's see here, that's minus 16 plus 32 minus 7, 9. So the vertex is at 2, 9. And the y-intercept, plugging in 0, that's just going to give me minus 7. Okay, so far so good. And for the x-intercepts, let me just set up the quadratic equation for you, and then tell you what the solution would be. You're going to get negative 16 plus or minus the square root of 16 squared, which is 256, minus 4 times a times c divided by 2a. And if you go through and calculate all of this, you should get two solutions. One at x equals 0.5 and one at x equals 3.5. So those are going to be our two x-intercepts. And putting all this together in a graph, which we could have been doing this as we went along, certainly. The vertex is at 2, minus 9. So to make sure it all fits on here, let's use this as 2, and I'm sorry, 2, 9. So 9 would be right here. So there's our vertex. We can see from A that this parabola opens down. Our y-intercept is at negative 7, which is way down here. And let me label the vertex there while I'm thinking about it. And then my x-intercepts are at 0.5 and 3.5. Okay, so the final graph here is going to be this very tall, very thin parabola. Okay, and I'll label my x-intercepts 3.5 and 0.5.